which is nothing but the network analysis. So here we will see some of the basics related to the electrical circuits. So first of all, let us understand how the series connection will be. Okay, series connection in the sense any two elements, if they are connected, one end of that is connected to the other element, other end, then they are said to be series connected. It can be either the resistor or voltage source or inductor, capacitor, whatever. Okay, so in between there should not be any disturbance. If you just observe here, the resistor one end is connected to the voltage source other end. Okay, where you don't have any other thing connected to this in between. I mean to say that there is no disturbance. If you just observe at the skits, okay, the kids are holding their hands. Okay, so all these are series connected. So here, if you just observe this girl and this girl, their hands are joined together. No other hand is joined to them so that there is some disturbance. Okay, so this type of connection is called as series connection. Now coming to the parallel connection. Okay, so parallel connection means you take any two elements, either it can be voltage, inductor, resistor, whatever you take. If you just observe this resistor and this inductor, if you just observe, they are connected end to end. Okay. One end of the resistor is connected to the other end of the inductor here, and the other end of the resistor of the same resistor is connected to the other end of the inductor here. So if you just observe here, those two are connected end to end. Okay, and from here there is another connection, and from here there is another connection. Okay, if this kind of connection is visible, then it is said to be the parallel connection. So here you can just observe these two girls are holding their hands. I can say that they are in parallel, provided here this hand will be joined to the other hand and this hand will be joined to the other hand. So if this side and this side, if there is some other disturbances, and they are connected parallelly like this. Okay, they are connected in this way. See, this girl's hand is joined with this girl hand, and this the other hand of the same girl is joined with the other hand of the same girl. Okay, and to their this side and this side, if it is connected to some other thing, some other hand or some other thing, then I can say that these two girls are connected in parallel. Okay, so here I'm just showing the analogy. Okay, so if this girl is R and this girl is L, you can observe that they are connected end to end, and both ends are connected to something else. Okay, so here it can be anything else. It can be either the voltage source or anything, or it can be the current source, whatever. Okay, so I can say that these two parallel elements are connected in series with all this voltage and current source. Okay, so you try to understand the parallel connection where R and L are connected parallelly. I mean to say that they are connected end to end, and this end and the other end is connected to some other network. Okay, hope this is clear. Now we will see other things related to the networks where as I was mentioning, that you have the voltage source. So voltage source generally it will be represented with plus minus symbol, and it will be shown like this. Okay, this is said to be the voltage source, or the other way of showing the same thing is with battery symbol, where this bigger lead is said to be the positive and the shorter lead is said to be the negative. Okay, so this is your voltage source, and here I'm saying this as this voltage source as independent voltage source, because if you just observe, the voltage value here will be fixed. If I say it is 5 volts, it will be 5 volts only. If I say this is 6 volts, then it will be 6 volts only. The value here is fixed. Okay, so if the value is fixed, then it is called as independent source. It is not depending on any other values. Okay, then comes the current source. Usually the current source is denoted with an arrow. Okay, where this arrow indicates the flow of current. Okay, so generally it is represented with I. Okay, this current source, the direction can be this way or any way it can be. It can be in this way, anyway. But if you have an arrow, then it indicates that it is the current source. Okay, so This current source is again independent source. We are calling it as independent source because even the current here of this current source will be fixed. So usually the units of current is denoted with amperes. So it will be 2 amperes. If I say it is 2 amperes, then this current source value will be 2 amperes always. Okay, in the same way, this current source, if I say it is 7 amperes, then this will be the current source value, and it is a constant value. So as I'm mentioning that these are the independent sources, I have different dependent sources as well. Okay, so generally the dependent sources are denoted with the symbol as shown like this. Okay, so diamond symbol will be used here to usually represent the dependent source. So if I have plus and minus here, then it indicates it is a voltage source. Okay, and let me write the value of this as 2IA. Okay, always in electrical circuits, I indicates current and V indicates voltage. Okay, so this IA is nothing but it is a current value. Okay, so if you just observe from the symbol, it is very clear that it is a voltage source, but the value here is 2IA. So this is not the fixed value. It is depending on some other parameter in the circuit. Okay, it is nothing but IA. As you know, it indicates the current. So here it is a voltage source, but depending on current value. So this is called as current dependent voltage source. This is the name given for this dependent source. In the same way, I have a voltage source. As I've already mentioned, plus minus always indicates it is a voltage source. Okay, so if the value here is like 3 VB, so V indicates voltage. Okay, so from the symbol, it is very clear that it is a voltage source. But on what it is depending? It is depending on VB. VB is nothing but the voltage source, voltage value. Okay, so it is called as voltage dependent. It is a voltage source and it is also depending on voltage value. So voltage dependent voltage source. Voltage dependent voltage source. So these are the two dependent sources with respect to the voltage. Similarly, I have current sources, dependent current sources as well. So where the arrow indicates it is a current source. Okay, so if I mention it as like 4IA, so from the symbol, it is very clear that it is a current source. And on what it is depending? It is depending on current value. So it is called as current dependent current source. So it is a current source, but it is depending on current value. So that is the reason it is called as current dependent current source. I have one more current source, dependent current source. So with the symbol, it is very clear that it is a current source. Okay, so let me write as 7V1. Okay, so from the symbol, it is very clear that it is a current source, but on what it is depending? It is depending on voltage value. So it is called as voltage dependent current source. Voltage dependent current source. So we have four dependent sources where two are with respect to the voltage source and two are with respect to the current source. Okay, so I will, as a summary, I will just explain you once again. So here, if you just observe from the symbol, it is very clear that it is a voltage source, but on what it is depending, I indicates current. Okay, so it is called as, this kind of voltage source is called as current dependent voltage source. And here I have from the symbol, it is very clear that it is voltage source and it is depending on voltage. Okay, so it is called as voltage dependent voltage source. Okay, next here, if you just observe here, it is from the symbol, it is clear that it is a current source and it is depending on current value. Okay, so here it is, the value is not fixed. Okay, so since the value is not fixed, I'm saying it as dependent source. Okay, so from the symbol, it is very clear that it is current source, and on what it is depending on current. It is depending on current. Since it is depending on current, it is called as current dependent current source. Okay, next. Here again, I've taken the current source only. From the symbol, it is very clear. And here, if you just observe, it is depending on voltage value. Since it is depending on voltage value, it is called as voltage dependent current source. Okay, as an example, I'll just draw one simple diagram where I have the voltage source. This is, let me write the voltage as 5 volts, some 5 ohms, and I have some dependent source as well. And I have one more resistor here. One more resistor here. Let this be 2 ohms. Let this be 3 ohms. And here I will write the symbol plus minus. I will write arrow here. And let me name this as IA. Somewhere here VB. Okay. So here if it is given as 3 IA and here it is given as 7 VB. Then from the symbol, so here I will just tell you which are the dependent sources and which are the independent sources. If you observe here, it is 5V. V is nothing but volts. So it is 5 volts. So this value is fixed. Okay, when it comes here, these two again, they are the sources. But what kind of sources? They are dependent sources. How I'm saying it is dependent sources? One thing is by seeing the symbol. Okay, here it is a diamond, here also it is the diamond. And other important way to identify it is here, if you just observe, it is 3IA. Okay, I indicates current. You have to check where that IA is. Okay, so if you just observe, I have IA here. Okay, so IA is nothing but current through the 5 ohm resistor. Okay, so this 3IA. So the value here is not fixed. Okay, so it is depending on IA in the same circuit. It is not somewhere, it is in the same circuit. Okay, so this is the, from the symbol, it is clear that it is a voltage source, but it is depending on current. So it is called as current dependent voltage source. And next, if you observe here, even this is a dependent source. You have it as 7 VB. Okay, 7 is anyway, it is fixed value VB. Okay, so the value here is not fixed. It is depending on VB. Okay, so VB, where it is nothing but the voltage across the 2 ohm resistor. Okay, so 7 VB. From the symbol, it is very clear that it is a current source. But on what it is depending? It is depending on voltage value in the same circuit. So this is called as voltage dependent current source. This is called as current dependent voltage source, and this is called as voltage dependent current source. Okay, hope this is clear to you. We will see you in the next class. Thank you.